All right, hello. Today we will be solving problem 2 in chapter 20. Consider Joule's apparatus as described in figure 20.1, and I have pasted figure 20.1 right here. The mass of each of the two blocks is 1.5 kilograms, and the insulated tank is filled with 200 grams of water. What is the increase in the temperature of the water after the blocks fall through a distance of 3 meters? All right, what do we have here? Well, in this problem, we will be using the first law of thermodynamics. But first, let's define what we have, what we are given. So M1 plus M2 equals M blocks and is equal to 3.0 kilograms. Where did I get that number from? Well, there are two blocks, each of them weigh 1.5 kilograms. Therefore, in sum, they weigh, or their mass is 3 kilograms. The mass of the water is 200 grams, or in SI units, 0.2 kilograms. Will be important. What is the increase in the temperature of the water after the blocks fall through a distance of 3 meters? Let's just denote the distance as d. You will see why. And also because the tank is insulated, Q is equal to 0. All right, now let's write down the first law of thermodynamics. Delta E internal equals Q plus W. Yes, there's a plus sign here. There could be a minus sign here. It just depends on the definition of work that you're using. Here, the definition is the work done on the substance instead of by the substance, which is why there's a plus sign, but don't freak out if you see Q minus W somewhere. It's still the same law of thermodynamics, first law of thermodynamics. And it is important to see here that delta E internal is equal to MC times delta T, except M of what? Well, the M of water, of course, because we are finding the delta T of the water, not the delta T of the blocks. And that needs to be consistent. But wait, Q is equal to 0, and this is basically the formula for Q. Why is that? Well, because in the text of the problem, the temperature doesn't change, but that doesn't mean that after something happens, the temperature can't change, right? Okay. Now, let's sub in the formulas. Q is 0 in the statement, and then F times D, but for the work, but what is F? Well, F is mg, but the M of what? The M of the blocks, because it is the work of the blocks times the D, and is equal to M of water times C times delta T, and the C is the specific heat right here. First, let's actually find delta T from this. Will be M blocks times D divided by M water times C equals delta T. What did I do here to get this expression? I divided both sides by M water times C, right? All right. So now we just see what the specific heat of water is. It's this number right here, 4,186. So let's just plug all the numbers that we have into our formula. 3.0 times 3.0 divided by m of water, which is 0.2 times 4186, close brackets, and we get this number right here, which is kind of big. Oh wait, sorry, you can't see it. Delta T equals this number right here, which is kind of small, admittedly, but that is to be expected. Work usually doesn't give too much of a change in temperature. When you move, let's say, your water bottle across the desk, it doesn't heat up too much from the friction. I mean, the water inside the water bottle doesn't boil from you moving it. And I'd say that's proof enough. Well, hope you found this helpful and see you next time.